This video is on carbon-13 NMR. As stated in a prior video, carbon-13 NMR is pretty common and extremely useful in organic chemistry. However, due to the low abundance of carbon-13 isotopes, the scans take a lot longer. It is a lot more tedious to run a carbon-13 NMR than it is to run a proton NMR. However, the information is similar. The carbon-13 NMR gives us the environment of each unique carbon in a molecule in the form of chemical shifts. There is no coupling though, so we only get single peaks for each carbon. It is also unreliable to integrate the carbon peaks, but a rough guide to figuring out how many carbons are present: if you compare two peaks and one is twice as high as the other, you could assume that there are twice as many carbons in that environment compared to the other. Once again, emphasis on the chemical shifts. If you use your cheat sheet, you can figure out what kind of environment each carbon is in. And when combined with the proton NMR, you should be able to get a pretty clear picture of what your molecule looks like. We can also modify the carbon-13 NMR to slightly different experiments with the same instrument to obtain even more information about the molecule. One of the more helpful ones is DEPT NMR, which allows us to identify how many protons are attached to each carbon. DEPT 90 will only show CHs, i.e. carbons with a single hydrogen on them. DEPT 135 will show you CHs and CH3s pointing upwards and CH2s pointing downwards. Applying all these methods also helps you to identify carbons with no protons bonded to them, as they do not appear in any. If you compare it to the regular C13 NMR spectrum, you will find out which carbons those are.